Welcome back. This video tutorial is to go over notes on solving systems of equations by substitution. To solve a system of equations by substitution, first you must isolate one variable. Here's an example. We have x plus 2y equals 6 and x minus y equals 3. I want to get one of these variables by itself. I see that I have a negative coefficient of a variable here. I'll move that one over to the other side. My end goal is to be able to find an x value and a y value that satisfies both of these equations. So I add y to both sides. I get x equals y plus 3. I've isolated a variable. Second, you substitute what that variable equals into the other equation. So if that x equals y plus 3, instead of x in the other equation, I put y plus 3. I'll take y plus 3 and substitute it into my other equation and rewrite it. Y plus 3 instead of x plus 2y equals 6. Next, solve the one variable equation. Notice all we have is y here. I can combine like terms. I get 3y plus 3 equals 6. Solve for y. I get y equals 1. Now I plug in that value for y. I know that my solution is going to be something comma 1. Last step is to plug the solved variable into one of the original equations. So if I know y equals 1, I can plug y for 1 here. I end up with x plus 2 times 1 equals 6. Or I can plug in 1 for the value of y in my second equation. I get x minus 1 equals 3. In both of these cases, you can tell that x must be equal to 4. So my solution to this system of equations is 4 for x and 1 for y. That satisfies both equations. Let's try some other examples. In this one, we have y solved for. We're looking for an x and y value that satisfies both of these equations. So we've already isolated one variable. We can check that off. Next, we want to substitute what that variable equals into the other equation. So if y equals x plus 3, I'm going to put that in for y. I get x plus 3 equals 5x minus 5. And I've substituted. Next, we're going to solve the one variable equation. We want to move our variable term to one side. We subtract x from both sides. We get 3 equals 4x minus 5. Then we're going to move our constants over to the other side by adding 5 to both sides. We get 8 equals 4x. Divide both sides by 4. We get x equals 2. So I'm going to plug in 2 for my solution of x. And now I can substitute 2, and for either one of these equations, I should get the same value for y. Either y equals 2 plus 3, so y equals 5, or 5 times 2 minus 5 equals y. So y equals 5 is here. Because 5 times 2 is 10. 10 minus 5 does give me 5. And there's my solution to the system of equations. If I put in x is 2 and y is 5, this makes both of these equations true. Let's try another example. Here I have the equation x equals 2y minus 8 and x plus 2y equals negative 12. X is solved for, so I can check that off. Substitute what x equals in for x in my second equation. So from equation A, I'm going to substitute 2y minus 8 into x in equation B. I end up with 2y minus 8 plus 2y equals negative 12. Next, I'm going to solve the one variable equation. I can combine like terms. I get 4y minus 8 equals negative 12. Add 8 to both sides. I get 4y equals negative 4. Divide by 4 to get y equals negative 1. So I replace y with negative 1. And my last step is to plug in negative 1 into either one of these original equations. So either x equals 2 times negative 1 minus 8, or x plus 2 times negative 1 equals negative 12. Either way, I end up with x equals negative 10. So my answer is negative 10 comma negative 1. And that satisfies both of these equations. My last example we're going to go over includes the distributive property. I'm looking for a coordinate x comma y that satisfies both of these equations. I'm going to first isolate one variable. It's isolated. I have x by itself. Then I'm going to substitute what that variable equals into the other equation. So instead of x, I'm going to put negative 2y plus 11. Because x is right next to a coefficient, I need to multiply 3 times this value. So I'll replace it with parentheses. Next, I'm going to solve the one variable equation. First, I'm going to do the distributive property. I get negative 6y plus 33 plus 3y equals 30. Then combine like terms. I get negative 3y plus 33 equals 30. Continue with my inverse operations. I'll have subtracted 33 from both sides. I get negative 3y equals negative 3, or y equals 1. So now I know part of my solution, y equals 1. And I'm moving on to the last part, which is to plug in the solved variable into one of the original equations. So if I know if y equals 1, I can plug this into my equation A quite easily. So x equals negative 2 times 1 plus 11, or 3x plus 3 times 1 equals 30. Either way, I end up with x equals 9. So my solution is 9 comma 1. Please be kind to yourself, be kind to others. I hope you have a great day.